In this video, we explored not arc length, but this other idea related to a curve, and it's the idea of curvature, right? And so we know from previous experiences that some curves are really curvy. So we might have a curve that spirals and then does another spiral over here or something like that, kind of wonky. We could have a connected curve where we have something that looks like this. Okay, so these two are really curvy, but then we also know from our experience that, well, some aren't curvy, right? We could have just a simple little arc like that, or better yet, straight line. Okay, so those aren't really that curvy. So we want to understand this idea of curviness. And what I want you to do is actually pause the video here and jump into the next video where Dr. Rognes does some computer observations with this idea of curviness with a parabola. So please take some time and watch that before resuming this video. All right, so hopefully you had some time to watch that video. And then really when we are talking about curvature, we're talking about how quickly it changes direction, but not necessarily speed, right? And what Dr. Rognes was showing in that video was the unit tangent vector. So if I call that vector t of x, the unit tangent vector is actually computed as the derivative vector for that curve, x prime of t, divided by, and then in order to make it a unit length, we divide it by its length. All right, and that's the unit tangent vector. Okay, so to measure curvature, we just want to look at how quickly the curve changes direction. So if I have a curve, let's say I have something like this, and then it curves in and spirals a little bit, okay? As I look at that unit tangent vector, okay, so I'm just going to kind of do this, kind of like what he was doing in the video, and do this a little bit more. I'm going to space them out, okay, and then right when it starts to spiral, that's when the unit tangent vector starts to change directions quickly. Okay, and so on and so forth. Okay, and so really over here at the beginning of our curve, this is where the unit tangent vector was kind of steady. It was kind of pointed in one direction, didn't move a whole lot, but then by the time we got to this right side of the curve, the unit tangent vector is changing quickly. Okay, and so we need a way to quantify that change, and it turns out that curvature is actually measured by the rate of change of that tangent vector. Okay, I want to get to that in a moment. Curvature is given by k, or not k, but this is the Greek letter kappa. Okay, so in your professional problem, if you need to insert kappa, you do something like /kappa to get it to insert, and then of t. And then we note that this dt vector, that's just the derivative of our tangent vector, but if we look carefully, that ds, that's per length unit of the arc length function. So that s is the arc length function. And conceptually, this makes quite a lot of sense. This is measuring how quickly the unit tangent vector is changing as we progress along the curve. Okay, so it makes sense. Okay, in the next video, we'll actually talk about how to compute this nicely, because computing in this form isn't so easy. I do want to draw your attention to this proposition 2.3 in the textbook. Okay, in that proposition, it gives two parts. So it says or the derivative of vector t with respect to time. Okay, again, we have a different differential. That derivative vector is perpendicular to the tangent vector, which that makes sense. Like a derivative and its vector are typically tangent. Okay, and then the second part of that says that the length of the derivative vector of the derivative tangent, the derivative of the unit tangent vector with respect to time is actually the angular rate of change. Rate of change of the unit tangent vector. Okay, which is really nice. But again, I just wanted to make sure that we note that yes, this is with respect to arc length, and these two are with respect to time. So just be careful when you're trying to apply these theorems. So stay tuned for the next video where we go through how to compute curvature.